Okay with that? Now, figuring out what's next. Remember, we don't go to the one straight across from it. This is your rotation that you're always going through, so I'm going to go one past it. This is your second pedal down. Okay? So again, don't go to the one straight across. Go one past it. Come down here. And then it's that same rule. So not there, but over here. So not there, over here. Okay, I've drawn 4 of them. So now I'm going to switch and keep going in a different color. So here, here. Okay, this guy got a little skinny. Yes.
Since it's signed, shouldn't you start on the point out of the order?
What's the sign of 0?
Isn't it 0?
Yes. So 0, 0 is where you start. Yeah. Because what's the cosine of 0? Like out at the maximum.
Oh, so it's cosine.
Yes. Yep.
If you were to draw your petals and they were to kind of overlap each other, because they're not very good.
A very good drawer.
Do you like loose points, or as long as your points that you're drawing the petals to are correct?
Again, if it's reasonable, I mean, this is not perfect by any stretch. My petals are very different. It is not super pretty. I clearly missed the middle a couple of times. This is fine. If you if it just looks like a hot mess and you're just sort of drawing circles all over your paper, yes, you would lose points. So a reasonable amount of I can't draw is okay, but just if you draw just straight lines instead of curves, that's not okay. You do. It is up and available for you.
So then is the answer the red petal?
Yes, red is the answer. And guys, if you want to do that on your test, if you want to graph the whole thing but do your answer in a different color, that's fine. Or even take a highlighter and highlight the part of the graph that's the answer. I'm completely okay with that. You don't have to go and erase, the first part of your graph. Question?
This is kind of related, but
okay.
Is that red? It looks a lot like orange.
I think I picked red. This one's orange.
Oh.
It's an orangey red? I don't know. It's what I have for red. That's my red. Unless I go in here and do something do you want it more red? Is that better? All right, here we go. Red. Yes?
Yeah, it looks the same.
Yeah.
I know, they're very similar.
I think it's just clear which one's red and
yeah. Not blue is the color I'm correct. Okay. All right, let me do the other one now. Let's see, -4 cosine 3 theta. And we did 0 to pi over 2, right? Okay. It's cosine. Is everybody okay with your first petal happens on the x-axis?
Yeah.
Okay. And since it's a -4, are you guys okay with 1, 2, 3, 4? That's where your first dot would be? Okay, 3 petals that you see, right? 3 different petals. So what does the spacing have to be between those 3 petals? Yeah, equal. So what 120 degrees? Yep, or 2 pi over 3. You could think of it either way. So you just have to find that on your graph. So from that starting point, I'm going to go 120 degrees, which puts me here. And then 120 degrees either side puts me there. Just look at your points before you start graphing and make sure, yes, they are actually equally spaced on the graph. Okay. And the -4 switches it as opposed to positive 4. Okay, I know you see 3 petals, but how many petals does this technically have from 0 to 2 pi? 6. This is 1/4 of that graph. So what is 1/4 of 6? 1.5. So I expect to see 1.5 petals. And it's from 0 to pi over 2, so it's the first 1.5 petals. Okay. Does cosine start at the pole or out at the end of the petal? Okay, so I'm starting over here. Remember, the direction we go for our angles is still counterclockwise. I know you had a -4 in front, but that's not a negative theta. That doesn't mean travel in the opposite direction around the circle. So if I'm starting at that point out there and I'm going in this direction, that's the first part of my graph. Come out here, and there's 1.5 petals, and you're done. Did we do okay? You got it now, right? Yeah, okay. Yeah.
So do you always start the graph going in the positive direction, like when you're drawing?
Yeah, because your angles, we haven't done anything where you're actually graphing negative angles.
Right.
It's always like from 0 to 2 pi or from pi to something, so.
Okay.
Yeah.
So, because it's going counterclockwise, is that why it goes downhill?
Yeah, because if you went this way first, do you see how that's this angle? Yeah, wrong way.
So the direction determines where you go from the start, not the point.
Mm-hmm. Yep. Okay, guys, any homework questions before we get to notes? Yeah. Number 2, yes. Let me find what number 2. It was out there at 7, right? 1, 2, 3, 7. We'll pretend that that looks like your number 2. Okay. All right. You need to figure out how far is it out to here. Like, where is that point? Like, so from the pole out to that, how far is that? I think it's 7. Yeah, it's 7. So that means A plus B has to equal 7. Then how long is your loop? Okay, so B minus A has to equal 1. So what 2 numbers are we using? What 2 numbers add to 7 and the difference is 1? Okay. A has to be 3 because otherwise it wouldn't be an inner loop. No, that's it. Yeah. Anything else from the homework? Okay. Let's jump into your notes then. All right, guys, 8-5. So we're going to start graphing this r equals theta. We graphed r equals just a number earlier. Remember, that was a circle with a given radius. When r equals the angle, you will get a spiral. It's technically Archimedes' spiral, but we'll just call it a spiral. It's fine. We are going to plot some points for this. We're going to make the little table. So over here on the side, do a little r theta for me. Okay, guys, so think about it. If theta is 0, what is r? 0. Good start. All right, I'm going to do pi over 4 next. Okay, if theta is pi over 4, that means r is pi over 4, but what does that mean? Okay, so let's think about some decimals here. What is pi as a decimal? 3 point what? Okay, thought I heard someone say 3.8. No. Okay, dividing something with a decimal. What is pi over 2, guys? Without a calculator, you can do this.
1.5.
Good job. Yes, 1.57. And guys, I'm even going to approximate that to 1.6. Okay? We're graphing it on this lovely graph. There's no difference between 1.57 and 1.6. But turning it into 1.6 makes pi over 4 easier. 0.8. Okay. So if theta is pi over 4, we're going to say r is 0.8. We're just doing the decimal equivalent of that. So on your graph, you need to go out 0.8, so not quite to 1, and then around to the pi over 4. Okay. Let's do pi over 2 next. So what's that as a decimal? About 1.6. I'm going to go a little more than 1.5 up to pi over 2. Move it up a little bit. We could do 3 pi over 4. I'm just going to jump to pi. We know pi is 3.14. So 1, 2, 3 and a little bit. There at pi. All right, let's go ahead and do 3 pi over 2. If I know pi and pi over 2, shouldn't 3 pi over 2 be easy? 4.7. We'll say 7 for sure. So down here somewhere. And then the last one we'll do is 2 pi. What's that going to be? 6.28. These do not have to be perfect. Just eyeball it in between the two integers, okay? So that's somewhere off your graph, running into my table. So you just have to connect these in order, and you will see how it spirals. Yours is nice and curvy. I think the large spirals are harder to draw. Yeah.
Pretty much, as theta gets bigger, so does the radius, so it just goes out forever.
Exactly. Yep. That's exactly what's happening. Hey guys, the graphs we're doing today, we're doing spirals and then lemniscates. We're not going to do quite as much with the graphs as we did with roses and lemniscates and all that. I'm not going to really give you too many weird intervals for these. I'll definitely give you an interval for a spiral because otherwise it would just go forever. It would keep growing. But it's not as big a portion of your test as some of your other graphs.
It's like the interval for this one would probably be like pi or 2 pi.
Yes. Unless I did something weird and put a coefficient on theta, like if I put a quarter theta, I might give you a bigger interval then. Okay. All right, so any questions on the basics of spirals? Okay, let's look down here. Yeah, I'll post the video this afternoon. Okay, oh, thank you. All right. What do you notice that's different about this one? R squared. When you see R squared, that tells you this is a lemniscate. L-E-M, lemon biscuit. N-I-S-C-A-T-E, lemniscate. We are not going to make a table of values for this. They're pretty simple to graph. Okay, we've got r squared. If I think about just turning that into r, I'd have to take the square root of this, right? What is the square root of 16? 4. Could it be plus or minus 4? Okay. That is the length of your two, we'll call them petals. This isn't technically a rose, but they look the same. You will always have 2 of these petals when you do a lemniscate. And the maximum they will go out to is always the square root of whatever your coefficient is. But where are they? You're going to do that process the same as you did with roses. So this is a sine curve. So if I'm thinking about sine of 2 theta, where does that equal its maximum value of 1? Okay, so 2 theta equals pi over 2. And you can do the plus 2 pi k. You don't really need it here. Divide it by 2. What is theta going to equal? Pi over 4. And if you add pi to it, you get the other petal, which is the same as if you did negative 4 and pi over 4. Okay? So I'm going to go 1, 2, 3, 4 at pi over 4. Okay. So your 2 endpoints like that will always be directly across from each other, 180 degrees apart. Yeah. And this, guys, don't make these harder than they are. Don't try to do too much. Like, you should be able to just look at it and go, oh, here's my graph. Like, that's what I expect with this. And I'm not going to give you weird intervals on the lemniscates. Like, technically it would start at 0 because it's sine, but you're not going to have to worry about the order of these. You can just draw them. Kind of looks like a propeller of a plane. Questions on that one?
What happens if you get like 3?
Then it's not a lemniscate.
Is it still r squared?
Yeah, that's something just is wrong with that problem.
Is that even possible?
You'll always have 2 theta on them. Yeah.
So why does like it not doubly matter?
Because of the r squared, the way it's happening, like, it's really weird. I can show you, if you graph it on your calculator, you could graph like positive 4 root sine of 2 theta. Like, it's square root of sine of 2 theta, not just sine of 2 theta. So that's part of what causes it to be very different from the other roses. Okay. And you can see it on your calculator, but it's kind of ugly to enter. All right, guys, so turn the page. I want you to try to graph the one at the top for me. R squared equals 16 cosine 2 theta. Do not overthink it, just graph it. And then check with your neighbor, see if you agree. It should not take you very long to do. All right, guys. How long are the petals? What's the maximum? 4. And where are they? Yeah, 0 and 5. 1, 2, 3, 4. Okay. Yay? Good. No issues. Okay, do 2 more for me at the bottom. 1 and 2.
The petals would only be in those 2 places that we were on the x-axis or the y-axis.
Yep. That's what I'm saying. These are, don't make them harder than they are. You should just look at it and know your graph.
Those spirals are only gonna, just gonna be off, right?
Yeah. Yep. Yeah, this is, the lemniscates are the only ones you'll see are square. Check with each other, make sure you've got them.
You never get a spiral where it isn't just R equals theta.
You'll see the other ones we're doing today. We're going to do r equals 2 theta and r equals negative a half theta. But you won't ever get like a sine or a cosine in there.
There's a negative side or
For lemniscates,
Yeah.
I'm not going to give you any negatives. It's seriously just this basic with lemniscates. Don't go beyond.
It's like,
issue, Alex, so.
All right, how do we do? Piece of cake? Okay, any questions? All right, when you're ready, turn the page. You've got 2 spirals at the top of the next page I want you to try to do.
I don't have that. Missing pages. Yeah, he is.
yeah, she is.
Tear them out.
And now you're blaming it on me.
Give it all here.
Check your backpack a lot.
No, I don't know if I have any extras. I have 1. Make sure.
Right here.
See, I think you lost the last. You good? Okay. Yeah, if there's a 2 in front, I'm not going to make you graph like up to 2. That would not be fun. It's okay, Malak. It's possible that it just got torn off somewhere in the process.
Literally just like, yeah, but then the other one is negative 0.5.
It's just that's why you type, right?
Yeah. Because like because basically instead of pi, you're find the two pi.
You just multiply by least.
Yeah, exactly.
Not yet. Oh. And two.
It's still when you get like in a non-square number, you just approximate what's square.
It's just,
Yep.
that's what I got.
We split.
This one didn't go all the way. Got it.
Eli just wanted to grab extra.
Yeah, extra work.
All right, guys, let's go through these. So for number 3, you're just taking 2 times each theta value. So 2 times 0 is still 0. When I plug in pi over 4, what do I actually get as my answer then? Yeah, the 1.6, right? So I'm going to go out to 1.6 when I'm at pi over 4. What about when I'm at pi over 2? Where do I go? Yeah, 3.14. And then I'm going to skip just to pi. Remember, we've got a window here. So what's it going to be out at pi? Yeah, off the graph, right? Somewhere over here. So even though you only went to pi, it still covers a lot of ground. Okay. We okay on 3? All right, so number 4, same idea, except now instead of doubling everything, you're cutting it in half and you're making it negative. So let me make you a little chart just to make sure we see it. So 0, 0, we still start there. That's easy. When I plug in pi over 4, what do I get for the r value? Negative 0.4, right? Okay. You normally get 0.8, we're taking that, it's negative a half of that, so negative 0.4. So think about graphing that. You're going to go left first and then travel around pi over 4. So you're in the 3rd quadrant here, just kind of floating around there, right in the middle. Okay, then I'll do pi over 2. What do I get for pi over 2? Negative 0.8, yeah. So you're going to go left by 0.8 and then around to pi over 2. So you're almost to the 1 there on pi over 2. Then again, I'm just going to jump to pi. What do I get for the r value with pi? Negative 1.6, yeah. So I go left 1.6 and then travel around pi. So that's what your spiral looks like. Okay? Okay. The last part we have here is algebraically solving some of these equations. So the directions say find where the polar graphs intersect on the interval 0 to 2 pi. We're actually skipping number 1 and starting with number 2. Do you guys remember solving systems of equations in algebra? Okay, what were the different ways you could solve your system? Okay. Elimination. Graphing. Okay, good. Does everyone know what elimination is? Because my 7th period yesterday, baffled. I had to teach elimination real quick. Yeah, and it's going to like cancel out your, okay. All right, good. Just making sure we don't need a side lesson on that today. So it's good to visualize these and understand what's happening with the graph. And you're also going to want to do it algebraically with substitution here. So since they're both r equals, we can go ahead and just say 2 equals secant of theta. Do you agree that that's the same as 1/2 equals cosine of theta? That makes sense to everyone? Yeah. That's what your brain should be doing on your trig quizzes when you get secant and cosecant. You should be flipping those, okay? It's much faster. Your brain thinks faster in sine and cosine than it does in secant and cosecant. Are we okay?
Why does it equal 1/2?
Okay, secant and cosine are reciprocals, right? You good? Okay. All right, so what are my thetas? Where does cosine equal positive 1/2? And? No. Yes. Cosine is the x. Yes, yes. Okay. Those are just thetas, though. Again, think back to algebra. When you solved systems, your answer was an ordered pair, right? An xy, like you found the point where they intersected. We need the points where they intersect. So we need an r and a theta. So how could I find r? They gave it to you. Yeah, it's 2. If that wasn't there, if it was another like sine or cosine equation.
Just plug in the angles into secant of theta.
Exactly. Yep, you just plug it in and evaluate. So this one, I get 2 points at 2 pi over 3 and at 2 5 pi over 3. Now, we're going to think about these graphs. I'm going to make a little sketch for you to make sure we've thought of everything, okay? Okay, so r equals 2. What is that?
Circle.
Excellent, yeah. Centered at the pole, radius of 2. Okay. What about r equals secant of theta? What is that?
It's a line.
It's a line. What kind of line?
A vertical.
Yes, at x equals... Here, let's go through it. R equals secant of theta. We're okay that that's r equals 1 over cosine, right? So r cosine theta equals 1. So x equals 1. That's your line. Okay. Do you see how they intersect twice? Yes. Let me show you something on a calculator too, just so you can see it a little more clearly. Maybe. So on my calculator here, if on the left you turn it into that little line with like a circle at the end, and you do that just by arrowing over and highlighting it. This one I just have to keep pushing enter. On most of yours, you'll probably have like a little drop-down menu. And then my equation, so I'll type in r equals 2 for the first one. Here, I'll go highlight that again. We'll do secant of theta, so I'm just going to do 1 over cosine theta. And then in my mode here, I'm in radians, polar, all of that. This one here that says sequential and then that's simultaneously. I'm going to graph these simultaneously so that you can actually see where they intersect. Okay? All right, and I might have to slow them down. They might go too fast. I don't know. Let me change my window so you can see it better. Okay, what you're looking for when I graph it, the little circle on the end of each line as it's going around, you're seeing how many times those 2 circles run into each other, okay? So there's once. Twice. Did you see it? Okay, so they intersect more than 2 times, but that's on the XY plane. In the R theta, they have to intersect, it's almost like at the same time, okay? So not just that they overlap one another, but that if you're graphing it, they would actually run into each other at that point. Questions? Okay, let's try another one. All right, try number 3 for me. You guys try it, and then I want to look at it together and explain some things as well. But give it a try. Talk to each other. Check in, make sure you're doing okay. How many answers are you guys getting? 2, good. How many there are? Are you guys getting 1 pi over 3 and 1 5 pi over 3? Yes, okay. And again, I just want to show you on the calculator again, we'll make a little sketch here. What is r equals 2 cosine theta? Like, what is that graph? You gotta know what they are. Okay, yes, it's a circle on the x-axis over to the right. And you have a diameter of 2. Do you guys remember what actually happens with that circle? Like 0 to 2 pi? Do you remember that it traces over itself? 0 to pi would show you the entire circle, and then if you went to 2 pi, you would trace over it, okay? And the other one, r equals 1, that's a circle centered at the pole with a radius of 1. This is where it's kind of interesting. So we definitely see these 2 spots here where it intersects. But do you see how it looks like they intersect at the pole? Again, on the XY plane, they absolutely do. But r theta, they don't hit the pole at the same time. Oh, and what am I saying? There's not actually a point on the blue graph. It's a different one. That's just my center. Ignore what I was saying. Clearly, there's no point there. So we've got our 2 points. But I want to show you on the graph because it's interesting to see how that 1 goes around multiple times. So let's do 2 cosine theta All right, guys, so watch them graph. Especially the circle that's on the x-axis, see it go around 2 times, just to help your brain remember that that's what those graphs do. So one intersection, and then they don't intersect again until the second time around for that other circle. That's why it's a pi over 3 and a 5 pi over 3. It takes it that second time around for them to intersect again. Okay. Try number 4 for me. Yeah.
Is there ever a situation where like the two graphs overlap more than the number of intersection points that they're on?
So I don't want to say never, but well, okay, kind of. Let me show you what this next graph looks like, and then you tell me how many answers you think you should have. So cosecant would be 1 over sine. And then 2 sine theta. So to just look at the picture, it looks like 2, right?
Yeah.
But did you see it going around how it actually intersected 4 times?
Yeah.
Okay. Is that what you're asking?
No, so there's 4 different, those are the same points that were intersected at twice, right?
Different angles. It'll happen at pi over 4, and then it hits over here again at a different angle. So, all right, so try and solve this one, guys. There are 4 solutions. Four answers. Yeah. Yes, and this one, it ended up working out okay for you, but this is actually a horizontal. This is cosecant.
Yeah. I mean, I did it.
But yes, exactly, yeah. But yeah, it'll hit that line because that circle goes around twice. It hits the line 4 times.
So you have to write.
Yeah. Oh, let me email again and see. I will do it right now so I don't forget. Yeah.
So obviously this graph looks like it intersects less than it actually does because it imagines other graphs where it looks like it intersects more than it actually does.
Yes.
It's like if there's like four points where the graph overlaps and then it intersects twice.
Usually those happen at the pole because they'll look like they cross at the pole, but they do it at different times. And the easy way to check is when you figure out like, oh, well, this equation would hit the pole when theta is 0. If you plug 0 in for theta in the other equation and it doesn't equal 0, then they don't hit there at the same time.
Right. Okay.
Yeah. Okay. I think I know what you did.
I think I just did that wrong.
You can't just say r equals 1 for the cosecant of
I have to,
theta.
like-
You have to actually set cosecant of theta equal to 2 sine theta.
Oh,
Okay? Give me another couple minutes, guys.
so then if you were to define sine, like, so you become cosine, it would still be cosecant.
Cosecant you could turn into 1 over sine.
Oh, yeah.
Yeah, okay.
So I got this, but this is not a unit circle.
That's because the square root of 2 is not 4.
It's a root.
That happened yesterday, too.
Oh, yeah. Yeah. No, it's not 5. It's 2 5. Wait, yeah, no, 5
Yeah, let me show you. Whoops. It's got that little circle thing on the end of it. Yeah. And then in mode, pick simultaneous. Yeah. All right, guys, let me go through this one. So cosecant, I know I could turn into 1 over sine. I could multiply both sides by sine, and I'd have 1 equals 2 sine squared theta, which means 1/2 equals sine squared theta. How do I get rid of the square? And what do I need to remember when I square root? Well, not squaring it, that's a good step. Plus or minus, that's how you get the 4 solutions for this. Here, let me move it up a little, sorry. And what is the square root of 1/2? Root 2 over 2, yes. Okay, so are we okay with that theta is all of the over 4s? Yeah. And now, what do you get? Like, let's say the first one, my theta's pi over 4. I'd probably plug it into this r equals 2 sine theta. What do you get for r? Root 2, yeah. What about at 3 pi over 4? Also root 2 because it was sine. What about 5 pi over 4? Negative root 2, good. And are we okay? Negative root 2, 7 pi over 4? Yes? Okay, yeah.
I have 2 solutions, one 6 and one 5.
Bring it up here, let me see. Sort of wizardry did you do? Wait, why do we have? Oh, so you did. Okay.
That's just y equals 1, right?
Okay.
And then since r is equal,
R isn't just 1 here. You just assumed R was 1. Y is 1. That's where that horizontal line comes from, but it's not R. Okay. Yeah. Like, where'd that come from? So think about if I plug 5 pi over 4 into this equation up here. So I have r equals 2 sine of 5 pi over 4. That'd be negative, and that's, yeah. Okay. Let's see. Do I want to do one more? Maybe. Get my pages here. All right, let's try number 6, guys. It's number 5 for you. You don't even have this one on your paper. So it's your number 5. Let's try that. This will be our last one, okay? So you have to actually do like cosine theta, cosine pi over 2, plus sine theta, sine of pi over 2, like the cosine of a sum or difference, those formulas. And then put it, no, we'll just do this one. No.
All right, and then do you have any extra practice material on that Schoology for the test, or is it just
So I think there's an extra review.
usually for the test, I do all of them actually read things, and then I do all the extra practice.
So Delta Math is up too, and there you can always just do extras of those. So.
I don't feel very effective if I don't do the question.
Well, you'll get the fake quiz next time, which will be more paper-full parts of it for you, and then there is a review, a paper pencil review too. Okay. You can do it.
Or redo them. My memory isn't good enough to remember them.
Well, that's true. Yeah, you can always open them and do it again. Yep. Yeah. Guys, what are these two graphs here? 1 plus 2 sine theta and 4 sine theta. What are they? One of them's a circle. And an inner loop, yeah.
Yeah, you put 11.
Thanks. I made that very weird.
Oh my god. What
It is an inner loop in a circle. So guys, does it look like they intersect at the pole? Yes. On the xy plane, they would. With r and theta, though, they don't. Let's look at it graph again. Oops, maybe. Okay, so count again. Watch where the two little circly things that are graphing intersect. I see. Oh, well, maybe. Hold on.
Is it possible to come down and
1, 2, and then do you see they don't cross the pole together? You see it? Could it be no solution? Yeah.
yeah.
That's a thing that could happen for sure. All right, so you do just get 2 solutions to this one.
What happens if you get calculation, like, it's not just R equals.
Thank you.
Like, if you're given like R equals something and like R squared equals
I won't do that to you. They'll all be reasonable to solve. All right, guys, so this one, I'd be doing 1 plus 2 sine theta. Equals 4 sine theta. Everybody okay getting to 1 equals 2 sine theta? Just subtract 2 sine theta over. So where does sine equal 1/2? Pi over 6 and 5 pi over 6. And when I plug that in, I believe I get 2.
The square root of 10.
Approximate the square root of 10. Do not ask technology for that.
Slightly more than 3.
Yep. Okay, well, what's the square root of 9? Okay. All right, guys. Questions on the notes? Okay, on your homework, I'm going to have you skip one on the back, but let's, which one do I want you to skip? Yeah, skip 5. Try 6 and 7. Okay.
So Mr. Lake, are we not going to have the identity problem that make it use identity on the test?
Not like that. Mm-mm.
No, first one. It's not on our sheet.
Yeah. Yes. Yeah, guys, there is a Delta Math review. Don't forget. All right, guys, you've got a little bit of time. You are welcome to start on your homework.